mic is pretty low. I don't know if she's standing too far away from it.
Well, good day and welcome. My name is Emily Lakdawala and I'm with the Planetary Society. I am delighted to be hosting Mars One's first press conference. Mars One is an organization that has an audacious plan to settle Mars in 2023. What makes Mars One different from other organizations is their pragmatism. They acknowledge that while it will be very hard to get humans to the surface of Mars, it would be even harder to bring them back. If Mars One succeeds, it will establish the first human colony, the first permanent human colony on another world. Who would be crazy enough to sign up for a one-way trip to Mars? Well, we're about to find out. Today, Mars One is declaring its astronaut application program open. Are you willing to take the risk to leave everything behind to be one of the first 4 Mars astronauts? Our panel today will tell you about Mars One's plans and how you can join an international team of 2 women and 2 men with the right stuff to take this first brave step onto another planet. Our panel is Bas Lansdorp, co-founder and chief executive officer of Mars One, Gerard 't Hooft, Nobel laureate and ambassador for Mars One, Grant Anderson, chief engineer and co-founder of the Paragon Space Development Corporation, Norbert Kraft, medical director for Mars One,
audio way low.
and Brian Versteeg, mission concept artist for Mars One. But before the panel speaks, I'd like to show you a movie. This and a documentary are part of the press kit, which you can pick up over there or download from the website at mars-one.com. Brian, if you could please play the video.
The moon was man's first outpost, a first footstep in space. From the moon, we were able to look back at Earth and see ourselves from a different perspective, a sight that revealed a profound truth. The heavens are part of man's world. From this moment forward, the curve of evolution was bent. The perilous voyage into space was a challenge we were willing to accept and unwilling to postpone. The future of our species was now as much in space as it was on Earth. 44 years later, we're approaching the dawn of a new era. One that is characterized not by rovers and probes, visits or short stays, but by permanence. Mars. From now on, we won't just be visiting planets, we'll be staying. You will be staying. In our pursuit to find life elsewhere in the universe, the search for life on Mars begins on Earth.
So, today, the Mars One Foundation starts the search for Mars inhabitants. A search for people from all nations who want to settle on Mars. Mars One is a not-for-profit organization that is working on landing the first crew on Mars in 2023 and another crew every 2 years after that. This schedule is possible because we have built our mission around existing technology. We will use rockets that exist. We will use landing technology that's very well understood, especially right here in the USA. We will use life support systems that have been tried and tested. And we'll use robotic technologies to prepare the human settlement before the humans leave the Earth that are very well understood. This will not be easy. There is a lot of engineering and testing to be done before the first humans will land. But no new inventions are needed to land humans on Mars. There might be delays, there might be cost overruns, there might even be failures, but it can be done. It will be a mission of permanent settlement, a one-way trip. This is necessary because the technology to send humans from Mars back to Earth simply does not exist yet. And while that may sound really drastic to a lot of people, Mars One has already received more than 10,000 emails from more than 100 different countries of people who are interested to join us in this mission, who want to go. And it has actually been like this throughout the history of our planet. There have always been first exploratory missions, after which the settlers would follow. Mankind has already sent its robotic scout missions to Mars. The planet is habitable with the right technology, and now it's time to settle it. I will summarize our roadmap, but I invite everybody to take a look at our website where there's a lot of more information to be found. The website is mars-1.com. So a very brief summary of the roadmap. We'll land a first demonstration mission in 2016. The second mission will go in 2018. That will be a rover, and it will determine the exact location of the settlement. In 2020, we're sending a second rover to Mars, and all the hardware, the cargo missions that will put the hardware in place for the human settlement. The rovers will move all the equipment to the right location, and they will activate the life support systems. The life support systems will start producing breathable air and water on Mars, and when this is demonstrated, when it's determined that this is successful, the first crew will leave Earth in 2022 and arrive after a voyage of 7 months in 2023. Actually, exactly 10 years from today. So Mars One is not an aerospace company. We are not going to build a single component for this mission in-house. Instead, we will use suppliers that have already been building this technology for decades. We have discussed our plan with aerospace companies from around the world that have already built the rockets, that have already built the landing technologies, that have built the life support systems and the robotic systems that we need. We've discussed our requirements, our budgets, and our timelines with their engineers and their business developers, and we've used their feedback to come up with a mission design that is possible now. The resulting plan can take humans to Mars. The cost for the first mission, the cost for the first 4 people who go to Mars will be about $6 billion US. Now that sounds like a lot of money, and actually it is a lot of money, but imagine what will happen when the first people land on Mars. Literally everybody in the globe will want to see it. And in 2023, there will be 4 billion people with an internet connection. 4 billion people will be watching the same screen at the same time, and it will be the biggest audience ever, especially around launch and around landing. It will be the largest audience ever, by far larger than the audience of, for instance, the Olympic Games. So together with Mars One co-founder Arno Wilders, I founded Mars One when we found the revenue numbers of the Olympic Games. In London, the International Olympic Committee had revenues of more than $4 billion US. And the Olympic Games last only 3 weeks. That means that they had more than $1 billion US of revenues just because the world is watching. With that in mind, $6 billion is actually a bargain for a mission that will result in events that are so much bigger and that will last so much longer. The launch and landing will not be the only televised events. Mars One will enable people to watch and be involved as we select the envoys of mankind to the next planet, as we train them, and of course as they settle the next planet. These will be stories of heroes doing remarkable things, just like the athletes in the Olympic Games. So our goal, the goal of Mars One, is to land humans on Mars. And the stories that we will tell around it make it financially possible. But the story will actually do more. They will show people what a united world can achieve. They will show children from all nations that anyone can become an astronaut going to Mars. They will give the world something else to talk about than what's currently on the news. They will give us hope. And Mars One has already achieved quite a lot in the last 2 years. We grew from the 2 founders to a team of 10 people. We closed the contract with our first supplier. The University of Twente is since a month our first science and education partner, and we are supported by ambassadors and advisors from all over the world. A panel that includes an astronaut, a Nobel Prize winner, a scientist from NASA, and many other great people. Important steps that we want to take in 2013 are getting all our suppliers under contract and securing slots for the launches for our 2016 missions. But today we are opening the application process. And we call on everyone in the world who wants to go to Mars to apply. You can go to Mars. Well, I would like to end with a quote from Jim Lovell, one of the astronauts in the Apollo 13 mission. And he said, "From now on, we live in a world where man has walked on the moon. It wasn't a miracle, we just decided to go." I will give the word now to Professor Gerard het Hoofd. He's a Nobel Prize winner, he's working at the University of Utrecht, and he's one of the ambassadors of Mars One.
Thank you, Bas. Yes, I witnessed the news when the Soviet Union sent its first satellite into low Earth orbit. That was a Sputnik. And I experienced the thrill when Neil Armstrong made his first step on the moon. And I devoured the first blurry Mars close-up pictures made by the American space probe Mariner. The most exciting aspect of all these missions was that they showed that space travel is actually possible. We can go there. Now, most of today's space missions are done by robotic spacecraft. When will humanity go there? And then I mean, not just for a short trip, followed by some more short return trips. Until interest dwindles, cash dries up, and these places will be left barren again, apart from some piles of debris. We want to go there for a permanent colony. Now, my fellow scientists often ask, why send humans to Mars, or in fact into outer space at all? It is expensive, it's dangerous. They say robots can do better. I agree with the importance of robotic research. Robots may, in a more distant future, become intelligent, and then they can do everything. They can even make colonies. That will certainly happen one day. So it's not as a scientist, or not only as a scientist, but rather as a human being, I always dreamt of human expansion in space. It's possible. Not only our moon, not only Mars, but even other moons and planets in the solar system, in principle, are inhabitable by humans. And then as a scientist, yes, I can justify such attempts. As of today, science done by robots is still clumsy and very much constrained, much more so than when humans actually go there. And I think this is a scientific experiment all by itself. Not that we use humans as guinea pigs, but rather the question is, how can we establish a human colony on a place as barren as Mars? Can we travel to the planets? Are human-made ecosystems in space actually possible, sustainable? What would such a colony be like? Would it be able to grow on its own force? If we had answers to such questions, that would be absolutely terrific. Thirdly, this will be a big showcase for advanced science in general. I think for that reason, scientists should be in favor, and they may well profit from all this. And finally, scientists and engineers will be inspired to do many new kinds of research. They will be confronted with myriads of questions, of problems that they'll try to solve. This will lead to tons of spin-off science that can be used for other applications back home. Now, this project has very important ethical aspects to it. First of all, yes, the astronauts will not be able to return. So what if one of them decides to change his or her mind and wants to return? You'll have to say that's not possible. In place of that, Mars One is a company that has to make lifelong commitments to ensure that they'll feel at home where they are now. We must pledge to live up to those commitments. Another important ethical point is the health of the astronauts. It will be jeopardized by exposure to radiation and reduced gravity. Now, I'm not so much worried about the reduced gravity part. That will just be comfortable. It'll change the muscles in our body a bit and so on, but the expectation is that we can handle that. But radiation is possibly a threat, and Mars One must and will take all conceivable measures to mitigate that threat. We'll have to provide for shielding during the journey as well as on Mars itself. The habitats must be safe, and I will personally feel accountable if we haven't done absolutely everything to reduce the dangers that we might be confronted. When scientists discovered new planets and moons from the 17th century onwards, they frequently asked, why did God create all those planets? Was that for nothing? Is there no life on these things? Well, the answer that we're giving now is, let's try to change that. Let's try to populate those planets. When I first heard of this project, my reaction was very much like what I expect most of you will be thinking now. This is not going to work. 10 years is not enough time. $6 billion American dollars, it sounds like a lot, but actually it isn't. It sounds like not enough to me. So my reaction was, just put a zero behind those numbers. You're more closely to the truth, perhaps. Well, to be frank, I'm still skeptical. I think there will be pitfalls, setbacks, and complications. But from an optimistic point of view, the numbers do add up. This is, technically speaking, possible. Let's say that what we have in front of us is a roadmap. It's not carved in stone that the first astronaut will actually depart 10 years from now. Maybe, quite conceivably, there will be setbacks. If forces beyond our control will be holding us back, then we'll have to be flexible, adapt to the schedule such that it will be possible to follow it up. And in the meantime, all possible will be done to keep delays and cost overruns to an absolute minimum. So I think that Mars One has produced a business plan that's worth being pursued, and I decided to support them. Now, my support will not suffice. The project actually needs support from all of the Earth's population, or a sizable fraction of them. The astronauts, who will be great adventurers, heroes in every respect, deserve encouragement and admiration. They'll have to keep their act together in all conceivable circumstances. Actually, we will be looking for nearly impossible combinations of character traits. Intelligence, resourcefulness, courage, determination, skill. They must be psychologically stable and reliable, ambitious. Selecting these people will be a very difficult task, and a call is made on the public to help us select them. There shall be no exclusion on basis of race, nationality, religion, gender. We allow all people from the entire globe to compete. Thank you, and now I'll give the word to Grant Anderson.
Good afternoon. While the technical feasibility of the Mars mission encompasses a lot more than just the environmental control system, there's no doubt that the success of this mission depends upon the life support system on the surface of Mars working forever. The systems have to be robust, but they have to be repairable and maintainable within the capabilities of the candidates that this process is going to find. These questions of reliability and robustness in the long term have to be answered before we leave Earth. To be successful, we have to execute a measured and logical problem of applied engineering. Like any traditional engineering program, we have to make sure we have the requirements right. We have to do the design, build, and then test extensively before we leave. Early tests will need to be set up and run often and during the long term. Unlike other technologies, environmental control and life support doesn't lend itself well to accelerated testing. Biology works in its own timescale. A long-term tiered program to make us meet the reliability and make sure we're meeting the reliability mission is key. You know, Paragon joined the Mars One team to provide life support systems because we found we shared a common goal with Bass and his team of putting humans in space and on other worlds. Paragon has been working, Paragon signed the contract, I should say, back in February February 26th of this year. So we're not quite 2 months in to the efforts to define the habitat and the surface suit environmental control systems. But Paragon itself has been working for 20 years on the capabilities needed to do the Mars One mission. It's been a goal of the company's founders and a dream of its engineers, its technicians, and its staff. We are truly aligned with the mission of the Mars One program, and we want it to succeed. The contract asks us to finish the initial studies and present our results to the Mars One team early this summer. The results will be basic technology and schematics of the system required for the living and working on the surface of Mars, and the products will help us define the efforts and the schedules to do the program that Bass outlined. Paragon will do our part to make sure the Mars One pioneers that are living in the Paragon life support systems have the maximum probability of success that is available from our experience and our knowledge. While the commercial world, we in the commercial world have been looking at previous programs, and we've taken the knowledge, the hard lessons learned with money and with lives over the many years of the space program, and we're applying that and streamlining that to produce efficient and quick workable solutions for the issues at hand. Mars One, the Mars One program, I should say, is doing this right. Mars One is laying out a plan that will be logical stepping stones to the goals that are given by this program and with a high probability of success. Are there risks, and are we realistic about them? I do life support. I live with risk every day. These risks are there, but they're with every human adventure. And we must not allow those risks to prevent us from striving for the unknown, for seeking out adventure, and striking out towards being a truly planet-traveling species. Each Mars One team member needs to have one thing in mind in every task they do. Everything they do must be their best effort. Alan Shepard, the first American in space, told this story. The day before the Apollo 11 launched to the moon, Neil Armstrong, his friend, asked Alan to go and do the traditional walking of the rocket. So you go to the pad and you inspect the rocket from top to bottom. In the course of the inspection, Alan came upon a technician working in an access panel on the second stage of the huge Saturn V rocket. And Alan looked at the technician and said, "Do you really think this thing is going to work tomorrow?" And the technician looked him in the eye and said, "Sir, I don't know about anything else, but what I worked on is going to work." It's that attitude that is shared by this whole team. And it has to be shared by everyone working on this program, from the chief executive to the shipping clerk, every subcontractor, supplier, and the candidates that are going to be chosen through the application process that is being announced today. And with that attitude, it will succeed. I'd like to introduce now Dr. Norbert Kraft, the Chief Medical Director of Mars One.
Thank you, Grant. The application is already open of our website. So who can apply? Everybody who is older than 18 years old is welcome to apply. There are no constrictions where you come from. There's no restrictions if you have any degree. So we invite every nationality, every nation, every gender to apply on a website. It's open. And why do we have this openness? One is we want to make it the world can join in and not just specific nations. And the other point is, why don't we ask, he has to have a PhD, a master degree, whatever? Because there are people out there who did not have the chance or the luck to study in these things, but they are quite capable of studying and learning for that, so that's why it's open. Our key aspect is, if you apply, think about, do you have the abilities to be adaptable, resilient, creative, and do you have empathy? One of the key things is, can you really work with other peoples from other cultures together as a team? Anytime when a conflict comes up, and conflict is always there, it's when two people have different opinions. But what you do with it, that's the key question, that's what we're looking at. Do you use it to improve the group? Do you use it to work to a mature state? Or will it be used destructive? And that's what we are looking at. So really, we want that you really can work with the other people, work together in a closed room, because you have to think you will live in a very confined environment. You don't have a distraction that you can go out, go to a movie, can go to a theater. So really you have the daily life 24 hours with the other people, and when later on more people join, to live these people in a very small place. So that's your decision. We have, our website is open, and I want to show just one slide. So you go to our website, Mars One registration, you fill out your email address and your password, and then you can apply. Can you have the next one? So what we ask you are two parts. One is a private part, which means it stays in Mars One, and the other one is a public part. Public part means you write your motivational letter, why you want to go, and you make a video. A video about yourself, 30 to 70 seconds. So it has to be between the two parameters that we can stream it online, and if you decide to make it public, we will make it public. And there you answer 3 of our questions. One of the questions is why you want to go to Mars. The second question is what kind of humor is your humor. The third question is why would you be the person actually who wants to go. So if you decide it goes public, the 2 things going public, and that's where we will invite the public vote. So in our selection process, it's not only decided by some experts in one cabinet who decide, oh, this person goes. We invite the public to have the opinion too. And one part of the opinion will be the amount of likes how you get, but it will be not the decisive ones. This is round number 1, and then we have private question in this round, which we will look at and make, we'll use the decision to get you into round 2. So the next stage will be round 2. Round 2 involves you meet with a committee in your region. You don't need to fly anywhere. We will do it in your region, and you have to bring a medical certificate from your general doctor, and we will give you the requirements we have to healthiness, so you have no chronic disease. You can have corrected vision, but you should have with correction 20/20, for example. You should not have high blood pressure. When you bring that in, the committee will decide that you go in round number 3. Round number 3 will be televised. We will give you the ability to prove, and this is national. In your nation, we will give you the ability to prove that you're fit to go there. And the nation, in this case, can vote for one participant from their nation, which will go in round number 4. One of them, the rest, we will select. Round number 4 will be the international round. So all the selected one from the nation will come together, and they will start working in the groups, and we see how they will work as a group together. The participants after that will be between 24 to 40, which will be employed by Mars One, and we will start training them. We will train them in the United States, and what kind of training will they receive? So I said before, you do not need to have a degree, you don't need to have a special profession, because we will train you in dentistry, because you should be able to clean each other's teeth, for example, which is very important for keeping up your health. Emergency medicine, in archaeology, in biology, you need that you can grow your plants in your habitat. Astronomy and other necessary things. So you have to have the ability to keep up over the 6-7 years we train you with the training and show progress in that, because it is important for you in the end to survive on Mars, and that's why you will receive this training. At the same time, we will observe you and we will look how you do in your team. Are you working with your team? Are you effective? Are you constructive? Does your team mature and is mature enough to go to Mars? So I say always, you go to Mars when you sit in the rocket and not a minute earlier. So you have always the choice to say, I can't stand this, because most of the people don't know. I don't know how many people who will apply really were in an isolated environment before to really know what it does to them, if they can work with these people or not. So they have to try it out, they have to realize it. From our part, we see how it is. And then we will have in the end 6 groups of 4 people who are ready to go, and they will be equally qualified to be the first ones. And then we will ask the auditorium again which group you want to go first. However, they have to make a rating, because what can happen, and that's why we have 6 groups who can go. One person of one group, he might be chosen as the group number 1 to go, and he decides suddenly he gets cold feet. We have to pull the whole group out. So we have to go get the group number 2. Some person gets sick, we have to pull the group out. So it is not guaranteed that the first group really will go, because we don't know what happened in the last moment. Then the participant asked me, okay, what can we give back to the public? We want to do something for them, because they help us to achieve our goals, they help us to our dreams, but what we can give back to them? And I tell them, since we have it televised and you have a story, you run for a story, what you give them back is part of things. So one part is, anybody who cannot go to Mars can do the journey with you. So you will be their vessel to do the journey, because you will tell about your experiences, you will tell about your troubles, how you overcome them, and they can follow it. And I said, it's not like currently is that somebody selected as an astronaut and suddenly is on a space station and suddenly is back. I compared always to a soccer game. When the people watch a soccer game and then they realize somebody, tells you the soccer game starts and then you get the results. You don't want to have that. So we give them the people to make the journey with you and see. Then what we show, that different cultures, different generations, different genders can work together and overcome problems. So we'll see that it's really working, and they can take it back home and say, oh, I could use that solution to work with my teammates and to work with my boss, or to solve conflicts on that. And the last and not least is, you will have a colony on Mars, and we will strive for independence. So you have a total playing table to make your own holidays, to make your own vacation, you make your own laws, you make your own economy, whatever you think is best, and you create that, and everybody can watch and see how you evolve in these things. I want to stop here and move forward to Brian, our concept artist.
Thank you. Living on Mars will present many of the same challenges which humans face here on Earth, but with a lot less room for inefficiency. On Mars, they will have to grow their own food sustainably, they will have to generate and store their own energy, and they will have to build their own safe and secure living spaces with the materials they have available. And they will have to redefine the concept of waste to preserve the resources that they have. Without the ability to quickly replace what they need, they will have to be a truly self-sufficient, sustainable society, and the technologies they utilize and develop will help push the boundaries of our own capabilities here on Earth. The first settlers to arrive on Mars will live in inflatable habitats that will have the equivalent space of a very small apartment for each of the astronauts. They will have to set up their living rooms, their workspaces, and farming operations inside these units when they arrive. By covering these inflatables with soil, they'll be protected from the cosmic radiation that here on Earth is stopped by our atmosphere. From the moment they arrive, the growing of food will become one of the main focuses of the mission, and it'll be a full-time job for part of the crew. Although they will have brought food with them, fresh fruit and vegetables will extend their food supplies indefinitely, as well as increase their own quality of life and health. These habitats are not intended to be a permanent residence. Once the initial habitat is set up, the job of constructing larger habitats begins using the materials available. When people settled new areas of the Earth, they didn't bring all the wood that they would need to build their homes and schools and businesses. They used what they found when they arrived. Likewise, on Mars, we know that we'll be able to build bricks and concrete and glass, and eventually process steel and plastics. Humans have been building spectacular structures here on Earth for thousands of years with concrete, and Mars will offer the same opportunity. As the equipment necessary to utilize these different materials arrives, the potential and capabilities of the group increases dramatically. These larger spaces will have more room to grow food, more room to work, more room to play, and more room to live. With the use of very large video panels showing views from outside and projecting views of the sky on the ceiling, these indoor spaces can feel a lot less enclosed and increase the settlers' connection to their new environment. Establishing a new civilization on another world will obviously be a lot of work. But in the spare time, it could be spent much like here on Earth. A person could paint or read. If you're a writer, you write. If you're a musician, you can make music. And spending time collaborating with Earthbound researchers will increase the knowledge of everyone. At only 40% of Earth's gravity, elements of physical activity will be uniquely Martian. Activities like sports and athletics and dancing will change in ways only imagined here on Earth. Like any place on Earth where people congregate, the utilization of that time will result in the development of a uniquely local culture that will be a subtle combination of the diverse people whose interdependencies tie them together. Here on Earth, many people do jobs that they don't like, and jobs that don't inspire them, and jobs that they themselves don't feel serve any greater purpose than to put food on the table. Going to Mars offers the opportunity to establish humankind on another planet. These spaces will be more than habitats, they'll be homes. These settlers will be more than groups of people, they'll be a community. And Mars One will be there to see it. Thank you.
So that concludes the formal part of the press briefing. The panel will now take questions from the audience. I'll take some questions from people in the room first, and then I'll take them from Twitter using the hashtag #MarsOneLaunch. There will be a microphone for the questions. Please state your name and your organization before you ask. And we'll begin right up front here.
Hi, Clara Moskowitz with Space.com. And a question about the applicants. You said they have to be at least 18 years old, but is there a maximum age? And also, are you requiring that they all speak English or some common language, or can that be learned during the training session as well?
I think I answered the question. They have to be 18 years old and no requirement on the maximum of age, because somebody is with 60 figures and somebody is with 40 years old, so no requirement on the maximum age. They have to speak English in the round number 4 for the international round. So they have enough time. It will be around 2015 to learn it. We have the application for 11 languages. They can apply in their own native language, and they can make the video in their own native language. And the national round will be still in their native language, and after international round, then they should be able to communicate with the others in English.
Thanks. And quick follow-up is, what kind of scientific equipment will they be taking with them to do research on the surface?
Well, science is of course not the main focus of what we are doing. The main focus is getting those humans there and making sure that they survive. But the people that are going there will of course be interested in researching Mars. And they will have a large say in the equipment that goes there because they are going to do the experiments. If we give them experiments that they're not interested in themselves, they will work on growing food and on constructing their habitat. So it's really up to them. There will, of course, be a budget for equipment that they want to take for scientific research.
Roxanne Palmer, International Business Times. What sort of landing gear are we talking about when you're landing supplies, landing people? Are you going with like the sky crane model with Curiosity?
Currently, we are discussing the landing on Mars with SpaceX, but there are, of course, several companies in the US that have a lot of experience in that. In the case of SpaceX, where we have already had quite a lot of discussions, it would be a version of the Dragon capsule, which would be slightly enlarged, and so it would land without the parachute stage. It would land on retropropulsion. Yeah, I think that answers your question.
My name is Avo Hajian, and I'm an independent reporter. My question is, how long would the space travel take from Earth to Mars?
It will take about 7 months. At least in 2023, it will take 7 months to fly from Earth to Mars. And every year is a little bit different. And we will try to keep the maximum amount of time at 8 months. But for the first crew, it will be 7 months. So slightly longer than astronauts currently spend in the International Space Station.
Hi, I'm Amanda Wills with Mashable. You mentioned that the Olympics was your inspiration for how this sort of programming would go. Do you envision like the training process, and then once they're actually on Mars, do you envision it to kind of be like a PBS sort of documentary, or do you see it as more of a reality show, or will the advertisers sort of drive the type of programming? And will it be live, or will it be pre-recorded with edits?
Well, I think there's very many stories that you can tell around this human mission to Mars. So part of it will probably be live. For instance, when they go outside and they explore the surface, then it's definitely something that will be exciting enough to follow live. But for instance, inside, they will of course have their private time. This is their life. It's not just some TV show. It's their life on Mars. And first of all, Mars 1 would not allow there to be 24/7 cameras. But second of all, which is even more important, the people on Mars would not allow it. Don't forget that they are in charge. If they don't like a particular camera, they will put a piece of duct tape over it, and there's nothing we can do about it. So they will be very proud of what they have achieved. And if you're very proud of something that you have achieved, Norbert already referred to that, you want to tell that story. They will be thankful to the people on Earth who've helped them get there, so they will want to share that story with the people back home. So I think it will be all kinds of different events, and it will also be determined by what people here on Earth want.
David Freeman from the Huffington Post. You talk about the long-term commitment to these people. I wonder how you envision this evolving over a period of a decade, 50 years, 100 years. What do you see as the long term? And also, how do you assure that there will be people on Earth to support the group who are there?
Well, I think the last question is actually the most important one. How do we make sure that we can keep supporting them? We've discussed our plan with media experts from many different big companies, and they have assured us that for people to watch this, it will remain interesting for a very long time. But of course, you don't want to bet everything on that. So at the same time, we are designing this mission around existing technology, but while you're building new equipment and while you're spending a lot of money building the most efficient equipment possible, you will make very nice new discoveries. Professor Het Hoofd has already mentioned there will be great spin-offs, and Mars One will make sure that the Mars One Foundation is co-owner of these intellectual properties, and that in the somewhat longer term will create revenues for the mission. Then your question, where is this going? Of course, we don't know. We have the capacity to look for the first mission, to look to do out to the second mission. But after that, there will be so many changes in the technology that we can use, bigger rockets, maybe other companies or countries that are also going to Mars. Who knows what will happen? So what I personally hope, and Brian also referred to that, is that at some point the colony will be independent of the Earth and will declare its independence. And that would of course be a day of great celebration, because then it would really be a whole new civilization and a new planet.
Well, maybe I should add that, of course, we have to make a commitment, and you have to say if this world is not as perfect as that, and they will not be able to be completely independent. For instance, they will continue to need medicine, they will continue to need very, very advanced equipment which they cannot produce on spot themselves. We will have to make the commitment that they will be provided of these very essential needs. So every now and then, maybe not anymore every 2 years, maybe a bit longer time spans in between, we have to continue to be absolutely sure that they have everything they need from Earth. We can't just let them go, even if they declare independence. We might have to continue to give them some sort of support. So that will be the commitment that we have to make right now.
But do you expect the people to go to reproduce, to create a self-sustaining colony that goes on? I mean, are there going to be fertility tests to see if people are fertile before they go?
In the more distant future, you would expect that. That would be the ideal situation. But as Mars One as a company must also keep in mind scenarios that are not that beautiful, like they'll not be able to reproduce on spot, and then we'll still have to ensure that they have a good life. But of course, if things go as we hope and as we expect, then they will eventually be able to reproduce indeed and to spread by their own force the colony larger and larger. That means make new habitats, make new houses, and spread like a village, like a town, on Mars itself. That would be the ideal of all worlds, but we don't know when the world will be as interesting as that. Maybe there are scenarios which have more difficulties on their way. Then we have to be there to ensure that they still get what they need.
Narayan Lakshman from the Hindu of India. Two questions. One is, what exactly will Mars One's relationship with the people going to Mars be? So, for example, are you going to have a contract that tells them how they should behave, what they do? And I'm just wondering about this question of independence and how much control Mars One will have once they're there. My second question is also, I guess the one biggest thing that might be missing is just the ability to go outdoors and enjoy the outdoors. So do you ever see that changing, for example, like in the movie Total Recall, where a big atmospheric change happens?
I think for the second question, that's just a simple no, not anytime soon, for sure. Norbert, you want to take the first question?
The second question, the outdoor thing is, let's start with that at first. They know they are in a Mars suit, and I was 110 days myself in the isolation chamber, and I didn't miss it at all, not even a single day. And some reporter asked me, oh, did you see the white light and end of the tunnel before you leave? I said, no. But it depends on the person. So if somebody's an outdoor person and says, oh, I need my mountains, I need to smell the flowers, then it's not for him to apply for it. But not everybody needs that, and not everybody really misses that. The first question again was?
About the contract.
The relationship with us. Yeah, so the relationship for us is and this is our goal, and that's what I said before, we want mature groups. So we are not the father to tell the child what to do, and I don't think that's the right thing to do, to schedule their schedule every 5 minutes or whatever it is. We will train them, we will explain to them, we have our ideas, but as I mentioned before, even in the hierarchical structure of each single group, they can do whatever they want, they think is best for themselves, because we want to send mature people up there who make the right decision. Because think, in the worst case scenarios, they have 20 minutes to give us a message, and then 20 minutes from us to back, depends on the constellation, but that's the longest duration. So in 20 minutes a lot of things can happen, and if they wait for us to give them an answer, that makes no sense, especially in emergency medicine. So the key is they are mature enough to make their own decisions, whatever they think, because they have to live with it and they have to survive on that. And I don't think we here know what they have over there. So there's sometimes the conflict if you look about the International Space Station on ground. So ground makes some decision and the astronauts say, what does he know what I'm doing here? What does he know that I have to look for a film for 3 hours because it's actually in 3 dimensions, it's not laying just on a table. So I need more time to make the picture. So you see that's why they have to be mature enough, and that's our responsibility to send the right people out there.
I guess what I was driving at is there is the economic side of it, which is, you invested so much money and revenue depends on viewership. And you want to maintain some kind of, maybe you want to maintain some kind of control on what you're showing people back home. So how much will you control that?
That's what I said before about what Bas mentioned too, is we want the people that they say, what can I give back to the people? If they want to give back the stories, if they want to give back what they are excited about it, that the new civilization, the new holidays, whatever the festivities they do new, the experiments they find, these are the people and they will give this story back. We don't need to tell them, because if you start telling them all these things, sooner or later they say, I really don't want to do that.
Okay, I'm going to take several questions from Twitter now. We do have a lot of questions, so keep your answers to the point so we can get through them all. Amy Shira Titel asks, what about issues of planetary contamination? Sending men to look for life might kill any life that's there.
So planetary protection is very important. It means that if you go to a place, you don't pollute it. On our advisory board, we have the chair of the panel of planetary protection. That's John Rummel, who's helping us to make sure that our mission will be as little polluting as possible. But when you send humans to the next planet, you will always contaminate that planet, because you cannot sterilize a human like you can sterilize the Viking spacecraft. What's the most important thing is that you localize the pollution, so you make sure that humans don't go to places where there's the highest chance of finding life, to make sure that if there is life, that it will remain preserved. The most important thing is we have the right people on our panel, and they're helping us to make sure that our mission satisfies the requirements.
Alan Boyle is asking about the 2016 mission. How is it funded? How is it going to be launched? Who is building it? And what are the mission objectives?
Well, the most important thing for the 2016 mission will really be to demonstrate the landing technology, because we will be using that landing technology for all other missions. So we'll have 8 cargo missions before the human landing, and we'll all be in the same technology, such that we have a track record for the human technology before humans take place in it. The cargo will be mostly supplies, so hardware that will be needed for future missions, solar panels. It will be things that if we don't succeed in that first mission, it is not a big disaster, and it's not a big financial impact on our mission. And that's why we sent a supply mission before we sent the 2018 rover mission.
CNN Light Years says, what about communication robustness? We are currently in a blackout while Mars is behind the sun.
Yeah, for communications, we are talking to SSTL in the UK, and they are interested to give us the whole system from Mars service to Earth service. And probably there will be a second, so there will be a Mars synchronous satellite, which is always in contact with the outpost, and there will be a second satellite orbiting the sun in the same orbit as the Earth, in the L4 or the L5 Lagrange points, such that we have a relay satellite to communicate around the sun.
Can I ask the panel to pull the microphones a little closer to your mouth when you're speaking? Nick Savino says, considering the decline of public interest in moon landings after Apollo 11, how can you guarantee interest after landing?
Yeah, I think I'll answer that. I actually, when we found the revenue numbers for the Olympic Games, I didn't really know what that meant, because I'm a mechanical engineer. I've never worked in the media. So I talked to Paul Reumer, who's the inventor of Big Brother, and discussed what we are doing. And he said, and I asked him exactly the same question that is being asked now. Are people going to watch this for a long time? And he said, this is not about the first footstep and the first flag. This is about, this is a human mission. It's a mission where the humans are selected by the audience. These are not just random people going to Mars. These are our TV friends. These are people that will have fans all over the world, because they've been selected from the from the good people to be the most popular ones. These will be our ambassadors from everyone on this planet. And we will see also the human side of the mission. So we'll see some of the group dynamics. We'll also see some of the things that go wrong. And that's what makes it interesting. It's really, you will participate in the experience of going to the next planet. And that's why it will stay interesting for a very, very long time.
Let's see. Space Life says, what are the long-term aims of this project? Is it not short-sighted to put people on Mars just to be the first to do it?
You want to...
The long-term aim is to have a lasting colony, not just people land there, but people land there with the aim to stay and to establish a human outpost, which actually will be able to expand. Now, this expansion will not be easy, and at first we will need many, many resources from Earth to build, say, the next habitat on Mars using Martian soil, Martian materials, and so on, mainly, but not only, because you need substances you brought from Earth to make sure that the habitat is workable. But then we can, there's a possibility of extending the colony. And that's the more distant aim, to have a thriving new place there, not just 2 or 3 people living there, but having an entire community, which is as advanced and complex as the community that we have here on Earth. So on long term, we want to have a thriving human outpost on Mars, which can live all by itself, which needs very little support at all from Earth. That is the distant aim. How soon that will be accomplished is anyone's guess today.
All right, this is I'm going to phrase this question slightly differently. If the project folds before launch, what happens to the money? Are you going to split it among yourselves?
No. Mars is a not-for-profit organization, so even if we wanted to, we would by law not be allowed to do that. We've actually been discussing what exactly we would do with the money. Of course, one of the reasons that we feel might be that we run out of money. Then there's not much to spread. If there is still money in the bank of the Mars One Foundation, then we'll make sure that it has a purpose that is supported by the people who have supported Mars One. So it should be applied to space exploration. One of the things we have already discussed within Mars One is, for instance, donating that money to organizations that support space travel, human spaceflight, robotic spaceflight, like, for instance, the Planetary Society. So that's the most likely outcome, that will spread it amongst several space supporting other space supporting foundations.
Okay, I'm going to take 2 more questions from Twitter, then I'll return to this room. James Savas says, at what point would you need to leave home and be full-time with the project? And what contact would your family have with you during training?
You would leave home approximately if you're in the last 24 to 40 in year 2015. However, we will provide relocation for your family members. They can stay with you. Contact with your family, and that's a lot of participants ask me, when you're on Mars, for example, you will have contact with them, so you will have internet access, television access, a system similar like Skype and other systems exist. You can have video conference with your family and with your loved ones. But think always you have 6 to 20 minutes delay, you have a buffering system, but you will be able to keep in contact with your friends and loved ones.
Marcin Kublik asks, what psychological profiling will be used to ensure that the colonists won't develop depression or become suicidal?
One of the key things is we have them for 3 months every year in our habitats, and that's where we'll observe them, and we have big advisory boards which very announced team psychologists who works with team before. We have medical doctors in our board. We will observe them, work with them, we give them interviews. Every year they will go to a medical special certification if they are fit for the next year, and that will provide us to work with them and see if they are fit. And that's what I said, if you are in the 24 to 40, you're not going to Mars yet. There is always a chance you quit or we select you out until you're in the rocket.
Okay, I think I saw more questions in this room. All right, let's start back here in the middle, yes.
Hi, James Ellis, Topics Media. What is the biggest challenge, do you think, or the greatest chance of failure to this mission?
I think the biggest risk is the financial risk. And we know that this can be done. We are doing it with current technology, but what we need to do is spend the money on the hardware before we start getting the major revenues from the 2022 and the 2023 broadcasts. So we will, of course, have already now, when we do the astronaut application process, there will be the possibility for sponsors, for instance, to join in, for partners to join in. We will have the televised events next year, so there will be revenues, but it will never cost the amount of expenses that we need to do in the short term. So our biggest challenge is to convince sponsors, partners and investors to help us bridge that funding gap, the gap between expending the money and getting the money back from the revenues.
Great, and just a quick follow-up. How will settling Mars change life on Earth?
I think that's a question that differs for everyone, for every person. So for me, if I imagine that at this moment there would be people on a different planet also doing things, and that we actually, so humanity actually put them there, that would just mean something so amazing, being a species that actually spread to the next planet. For other people it could be scientific research, biologists who might be so interested in starting the real studies on is there life on Mars. There's people who, since we've launched our website about a year ago now, we've gone public, and we've received about 10,000 emails from people who want to apply. I expected that, but besides that, we also started getting emails from people from all over the world with other messages, like a whole school class in Thailand. I hope they're watching now. That would be really great. Of kids of 12 and 11 years old who wrote application letters to Mars One. They wrote them for fun. I mean, they knew they were not eligible yet, but they made really good letters explaining why they would like to go to Mars. I do a lot of sports, so I'm really healthy. I should go. We've received an email from a guy who emailed us. I quit my studies, but after reading about your project, I'm considering picking them up again because I now see the point. He never wrote back if he actually did that, but just to receive those emails because we together have started the project is really amazing. And these kinds of emails really give us the confirmation that this is something that touches upon a lot of people.
Okay, and before we continue, I just want to tell people that the press briefing will go until 1:30, so that's another 27 minutes local.
Hi, I'm Victoria Jaggard with New Scientist. I had a question. If you could speak a little bit more about the physical medical requirements for the people who will be going on the trip. I understand the desire for openness in saying basically anybody over 18, but it seems like we've learned a lot from astronaut medical studies about the type of people who are physically qualified to survive in these kinds of extreme environments.
Yeah, you have to think, so our first stage is that they should not be, which makes it logical, have chronic diseases. They should be able to move their arm and hands. You have to do extravehicular activity. Second, you have to see well, because you want to see what's around you. Of course, you have to think you shouldn't have a cross on your head, otherwise you can't put the helmet on. So basically, these are the basic requirements. Do we want somebody who is a marathon runner? He doesn't need to be. Because think about on Earth, you have, let's say, 100% gravity. On Mars, you come with 38% gravity. So anybody who's coming there is Superman, more or less. You can jump higher, you can run faster, so you don't need to do fitness. Of course, you should not have a high blood pressure. You should not have bad blood work, which means high sugar, too high cholesterol. So if you're a normal, healthy person, then you are fit on that. There's no special fitness requirements, because you have to think for an astronaut who goes to the space station with zero gravity, they lose some bone, they lose muscle mass, and they come back to Earth with 100% gravity. They have to be fit when they come back on Earth to survive the gravity. The ones who go to Mars, have only 38% gravity. They don't need to be as fit as you want to come back to Earth.
Hi, my name's Kylie Sobel. I'm a freelance reporter. You said the risk is a financial risk. The greatest risk is the financial risk, which I assume is going to be mitigated through the media collaborations. Can you detail what you envision that being? Is it going to be shooting a pilot with the advice of the man from Big Brother? Is it network syndication? Can you kind of detail that a little bit and how you plan to present this to the public?
Well, the first thing we'll do now is start the astronaut application process, and there we will have a good platform to show to the world that this is something that the world is really interested in. And from there, we will get the interest from broadcasters. We are already receiving a lot of interest from them. What we plan to do specifically is go to the MIPCOM conference in Cannes in the end of this year, and show the ideas that we have for formats that we can televise. For instance, the astronaut selection, so the national series of the astronaut selection process. But of course, there are so many things that you can do. And right now, we're a small team. We're just 10 people working in Mars One. And one of the things that we need to do soon is extend our format development team to make sure that we make use of all the stories that there are around this mission, and make sure that we tell them to the audience.
Hi, I'm Fran Berkman. I'm with Newsday. I was actually just wondering about the goal of launching 10 years from today. It's something that sounds so good, and it's so tangible, but I'm wondering what went into determining that that's possible. I mean, Professor Hooft already said that he could envision delays might be possible. Just what went into coming up with that date?
Well, what we did is we made a plan that is possible with existing technologies. So we've looked at what technologies are available and can we construct from those puzzle pieces a plan to send humans there and to keep them alive. Then we contacted the companies of the technologies that we used, and we asked them, we told them these are our requirements, can you do it? So we visited them, we talked to their business developers and their engineers, we talked about the budgets, the timelines, and we've discussed, is it possible in the timelines that we foresee? And well, I think Grant can elaborate a little bit on that in the case of Paragon, but we really have designed a mission that is possible in those timelines. And of course, I've mentioned it in my speech and in my talk, and Gerard Hooft has mentioned it in his. There are always, whenever you do things that haven't been done before, there's always the risk for delays. Even in railroad projects here on Earth, where we have done it before, there can be delays. So, of course, there is this possibility, but the plan, the timeline that we have set out is a realistic one, as long as no major failures occur.
Yeah, just to elaborate on that just a very little bit, is that that's why I emphasize the applied technology in my part of my talk, is that when Vas came to us, we were looking at what he wanted to do, and there are no technologies that need to be developed. What happens is you need to develop the hardware. So it's analogous to building an airplane. Everybody knows how to build an airplane. It still takes many years to do it, but you have a pretty good idea because you've done something. You have the technology already out there. So that's what we see with this, is applied engineering and building parts and testing them adequately to go. And we felt within 10 years that was very achievable.
I don't mean to be the glass half full guy, but given the number of variables that this undertaking has in it, thousands of variables of all the different things that go wrong, have you done a statistical analysis of what the percentage possibility is of failure on this? And meaning, you know, out of the thousands of variables, one of them goes wrong and these people all die either from launch or 5 years from now, or has there been a statistical analysis done on that? And will you be telling applicants the percentage possibility that they might not get off the ground or will not come back?
Well, of course, the applicant, I'll start with the second part. So of course the applicants, they will be training with us for 7 years, and they will have worked with all the parts of the technology. So they will know everything about the technology and everything that can go wrong. And of course, it's our obligation to tell them all the risks and give them that percentage. Right now, we cannot determine that exact percentage because the hardware is not built yet. So we need to have the detailed designs of the hardware to take all these estimations to the next step. But we have designed a mission that's as simple as possible. So I'm very confident that we can provide robust hardware to the people who are going there. You talk about the risk of launch failure. The launch vehicles that we will be using will have been tested many times before we launch. But space travel is always dangerous. Even the space shuttle, which had been operating for a very long time, still had a big failure. Space is a very unforgiving environment, and there are always things that can go wrong. And the applicants will have to decide for themselves, do I think it's worth the risk to go? But we will have, because for instance we are testing our landing systems 8 times with cargo before the humans land. That's a lot better than, for instance, the comparison to the moon landings. The rocket was tested only a few times. The moon lander was tested here on Earth, but was never tested in the moon environment. It was never tested to take off. The re-entry in Earth with the very high velocity from the moon was only tested once at the full velocity and another time at something pretty much close to the full velocity. We will have tested all our equipment to much higher levels of certainty than the moon mission. So it will be much safer than the moon missions were.
Hi. My name is Minty Grover from Alexander English. Just out of curiosity, a more theoretical question. Would any of you consider being a participant in the mission? Would any of you go yourselves?
Okay. I was asked this question many times, and I explained that when I'm retired, definitely that would be interesting for me to go there, because the low gravity would be nice for my body when I'm old, because my bones wouldn't be so hurt so much, my bone density wouldn't matter. And there is, I put this always as an interesting point in, it's a beauty farm from that, because your blood shift, as the fluid shift into your face, you get less wrinkles, you look younger already. So I definitely consider when I'm retired might be going there. Currently not, but I think I'm better here to support and help the astronauts to go there.
Yeah, I started 16 years ago. The original idea arose in my mind to do this kinds of a mission, really because I wanted to go there and explore Mars. But it happened when I saw the pictures of the Sojourner rover. Right now, for me personally, I have a really nice girlfriend, and she doesn't want to come with me, so I'm staying right here. But this is such a great thing, and I will be extremely jealous when the first people leave from Earth to Mars. It's still my dream to go, and I'm torn, but still deciding not to go.
So if your girlfriend went with you, you'd go?
Yes, I would definitely. So, for instance, I would definitely go if my girlfriend was with me. And for me, the one-way mission aspect is really no issue at all. I would be perfectly comfortable with. I mean, it's a whole new planet that you can explore. How are you ever going to get bored there? You walk around on the surface. Every rock you pick up, you're the first one to pick it up. Who knows what you find? That's just really exciting to me.
Can I have a show of hands for how many people? Okay, so I'll take 3 more questions from the room, and then I'm going to go back to Twitter. So back up front here.
Roxanne Palmer, International Business Times. Is there any plan to send an animal or animals up on any of these preliminary flights?
Well, actually, we're talking to a Dutch university about the food aspects, and it's actually very likely that there will be insects going to Mars pretty soon, because insects are a very good way to use the remains of plants and eat the insects. And in Holland, it's not very common to eat insects, but there are of course very large portions of the Earth where this is very normal. So definitely yes. At some point, certainly, and I think that over time, more and more things will go to Mars, and probably bigger animals are also part of that.
But like any any plans yet for like mammals to go up before the humans, just to see what the effects are?
No, there's no plans.
Hi, Clara Moskowitz with Space.com, and I'm wondering what the fee to apply is, and also whether there's any chance that the astronauts that end up going could also make money, or their families could, via merchandising or other kind of deals like that.
The first question, the fees to apply. So yes, there's a fee to apply, and I'll explain why. At first we want that the participants are serious to apply, not somebody wakes up in the morning and say, oh, I have nothing else to do, apply for Mars One. Second, we don't want that some people just spamming and apply 100,000 times, because we read, and this is very important, we read every person who applies. We read every person precisely. We need time to do that. So there has to be a fee that we don't want to unuse our work, what we do, and we take every application seriously. But the price to apply is different for each country, because it's according to the national gross income. It wouldn't be fair the country where the people don't earn much pay the same one like a very rich country, people earn very much. So it is different for each country how much the price is to apply. The revenue, maybe you talk about the revenues about the family. So we will support from Mars One, of course, the families, and the people will get a salary, and they will keep up the salary, so we can provide for their families back here. That's for sure.
Hi, I'm David Freeman from the Huffington Post. Have you had any, I wonder what sort of feedback you've had from different space agencies, NASA and other space agencies around the world, or if there have been any objections, or is there any need felt, do you feel any need to seek permission from some official body?
Well, we will need, for launching our mission, we will need approval from the launching state. We've met with very many people, of course, from several space agencies, especially from ESA and NASA, because we're located in the US and Europe so far. And the engineers in ESA and NASA, of course, they want nothing more than humans to go to Mars. But I think for the organization, for organizations like ESA and NASA, or the Russian Space Agency, or the Japanese Space Agency and the Chinese one, for them a one-way mission would be something that is something that they really have to get used to. So I think before we will have the first space agency really partnering with us, that will take some time. At the same time, we do of course build on the technology that has been developed for these space agencies by companies around the world. For instance, Paragon has been building things for NASA already, and we are very grateful for the space agencies for all the work that they've done so far, and it would not have been possible to say here that we can do this with existing technology without the help of the space agencies.
So returning to Twitter, Steve Hedden asks, will there be problems with pregnancy at lower levels of gravity? And before you answer, I just want to offer the editorial comment that pregnancy at 38% gravity sounds so much better than pregnancy at Earth gravity.
I can say only one thing. We definitely will start out at first with animals and see how the pregnancy works with animals, and see how it works out, what problem will occur, and what the children will be who come, and then we will go from there after we have these results and think about human pregnancy on Mars. So therefore we don't know about 38% gravity, what it makes for babies and for the pregnancy.
Ingo Girth asks, how do you plan to select the landing site?
Well, we already know sort of where we will land, because we are dependent on water that's available on Mars. So it will probably be north of 40 degrees north latitude, and because when you go more north than 40 degrees north latitude, there's enough water in the soil to mine. And it will probably be more than 45, will be less than 45 degrees north latitude, because we are building this mission on solar energy, and the closer you are to the equator, the better it is. Furthermore, we would like the location of the settlement to be at a low elevation, and there's a large range of low elevations that at that latitude. And in these specific locations, we have not determined completely yet where we will land. And we're planning to organize a big workshop where we will ask the help of experts from all over the world to help us determine the exact spot where we should go. And finally, we'll send the 2018 rover mission to that location. And in that location, the rover will drive around and determine the exact spot where we will put the settlement, which will determine on a nice flat surface, and actually determining if there is enough water in the soil to use for the human settlement.
Jeff Faust asks, can Mars One provide more details on its $6 billion cost estimate for a human Mars landing, including an itemized list of costs?
Well, actually, we don't want to do that. I can tell you that we've discussed the budgets per component with our potential suppliers. But for competition reasons, it would be very stupid for us to actually give the prices that have been quoted to us per component, because that would make it very easy for competition to go under it, but not too much under it. So the exact prices that we are expecting to pay per component, we will keep confidential.
Jeff has a follow-up. How does Mars One plan to maintain long-term interest in its missions to sustain extremely high prices for its media rights?
Well, first of all, we have discussed this with the media experts, and they are absolutely convinced that people will keep watching, because this is the biggest thing that humanity has ever done. But second, at some point we won't need those revenues from the media anymore. Even though we believe that they will continue for many decades, we won't need them because we will have other revenues, for instance, from intellectual property.
All right. Robert Perlman says, multiple TV networks have failed to fund cheaper, shorter space station trips. Why do you think they'll fund Mars flight?
Because they were cheaper and shorter space flights. The key to the interest of people is doing something that is so great that it will capture the attention of everyone. If you do something that has been done before, like a suborbital flight, which has something that was even less dramatic than the first human that went to space, this is just something that people are not interested in. It's about the human adventure of discovering a new planet. And that's something that people are interested in. So it's exactly the greatness that makes it possible to finance this.
All right, Nancy Atkinson says, what does the panel see as the biggest hurdle to overcome to make this a reality?
Well, I think we commented already on the. In my opinion, it's the financial aspects. But maybe one of the other panels has a different. You want to go into psychology?
No, I can just go. If you point it out from the human point, for the human view, what is the big hurdle? The big hurdle is that you really can work in a team, and the team works in the end, because you have to depend on every team member most of the time, and you just can't say we lock this guy out, we lock this guy out. You have to work together and really to achieve the goal over the end of your life, basically. You really depend on each other. You just can't go home like a job and say, oh, my boss, I don't care about him anymore. So that's the biggest hurdle. And can you really work with the other culture? Can you really work with the other guy around it 24 hours a day? And can you be the real good team? I think this is one of the personal challenges.
Okay. Mr. Aguirre asks, what implications or issues will there be with international law?
Right now there is, of course, the Outer Space Treaty. There is the Moon Treaty, so there is some law on what you can and cannot do in space. But before humans will go there, which will be in 9.5 years from now when they depart, and 10 years from now when they land, we will need to have regulations in place. And one of the advisors on our advisory board is Tanja Masson-Zwaan. She's from the Space Law Institute in Leiden. She's helping us identify these issues. But in the end, as Norbert has already commented upon, once there are humans on Mars, there will be also their local interests which they will defend, and that is something that we on Earth will in return have to respect.
All right. An anonymous journalist question: why the application fee, and how does it vary?
It's about for countries that are on the poorer scale of the gross domestic product per capita. And it's about $38 off the top of my head here in the US. And there's some countries that are richer. I believe the highest fee is $75. So we've really tried to make it so that for people in every country it is something that they can afford, or that they can gather the support for to help their friends, for instance, to support them to make it possible.
Liam Kennedy says, why is it more advantageous to set up a colony on Mars before creating one on the moon?
I think there's a number of reasons. There's first the technical reasons. So on Mars you have an atmosphere, while on the moon you have no atmosphere at all, which protects you against radiation and micrometeoroids. Mars is orbiting its own axis in about 1 Earth day, only 40 minutes longer. So it gives you a nice, good day for your solar panels to recharge the storage systems, and not too long a night for the storage systems. There's lower gravity on Mars, so it will be easier for humans to live on the moon. There's lower gravity on the moon, so it will be easier for humans to live on Mars. But I think what's the most important reason is actually, again, related to the previous question. If we were proposing a mission to the moon, I think there would be much less interest from the world, and we need the interest of the world to make this happen. So it's actually for us, even though a mission to Mars is further away and is something that has not done before, it's easier to finance a mission to Mars than to finance a mission to the moon with our business case.
So, I think eventually the answer is we should also get colonies on the moon somehow. I also been in favor of tying that as well. So we should try to get humanity everywhere where we can settle. And so the moon is a place that we should not forget. And maybe in the not so distant future, it will be possible to have humans on the moon as well. And of course, yes, there are these problems that we have on the moon that we don't have on Mars, and vice versa. Mars is a much longer journey than the moon. So some things are easier on the moon, some things are more difficult. So on the long run, I don't see why we should not have a colony on the moon as well. So maybe there'll be another Moon One organization which will put a colony on the moon. Why not?
Okay, and I'm told that this will be the last question. Why do Mars One and not spend all of this money on something else, like to improve people's conditions on Earth?
Well, I'm afraid that we're spending $6 billion in the next 10 years to make a Mars mission happen. And I'm afraid that 600 million per year is not going to make the biggest influence on an Earth with an economy that is so much bigger than that. But more importantly, I think that Mars One is its own business case. I don't have a business case to solve the problems on Earth. If anyone else does, then I really would advise them to work on that. I have a really good business case to get humans to Mars, and I believe that there's a really good reason to do that too. And even having humans on Mars, I think, will make the Earth a better place. There's so many things that we can do around a human mission to Mars to help in that. There will be spin-off in renewable systems, there will be spin-off in all kinds of systems, in medicine, and even small things that we can do. We can put two people from nations or groups of people that are in conflict in the same group, and we can show that they can become friends and that they can cooperate together, and maybe we can with such small gestures make some changes here on Earth.
All right, well, that concludes the press briefing. I want to thank you very much for your attention. If there are media out there with any more questions, you can email them to info@mars-1.com. Thank you, and thanks the panel very much. Good day.
Thank you, Emily.